Alrighty guys, here is going to be 8.2, so these will be your notes for either Wednesday or Thursday depending on your class period. So to start out, we're going to start out with the formulas here. There's two. They're very close to each other, obviously. You have growth and you have decay. Okay, so both involve the same numbers and letters, if you will. However, the only difference between growth and decay is with growth you have a plus R, with decay you have a minus R. Okay, so each thing stands for something here. So A is your initial amount, so whatever they give you before any growth or decay starts. So oftentimes this is a population or a price of some kind of item. And then they will give you an R, a rate. Okay, so this will be either a growth or decay. So you got to pay attention. So this is often done as a percent. So when we write these, we have to convert it to a decimal. So don't just put the percentage in, you have to convert it to a decimal. Okay, then you also have to pay attention to some key words. Okay, is it growing? Is it increasing in value? Is it, decaying? Is it decreasing? Is it depreciating? Okay, so you got to look for some keywords to tell you which one you're actually using. And then finally, to the x, that x is actually the time. So whatever interval is passed, that's what we're looking at. Okay, so let's just do an example here to kind of show you what it looks like. Okay, so this says a computer valued at $6,500 or $6,500 depreciates at a rate of 14.3% per year. All right, first thing is just write a function. Okay, so what we're going to do is we're going to say, okay, what is our key word? Okay, our key word here that tells me that this is a decay problem is depreciates. Okay, depreciates means to decrease. So this for us tells us that we need to use decay, which means the formula I'm looking at is decay. So it's this one on the right here. So I am trying to figure out a formula that looks like this. 1 minus R dx. Okay, so there's my formula. All right, now what I have to do is I have to transfer the numbers in. Okay, so remember, the A is the initial amount. Okay, so the initial amount that they give us is 6,500. Okay, the next piece is the 1 minus R piece, right? So 1 minus, okay, and now the R, the rate is 14.3, we have to convert that to a decimal. So when we do this, move the decimal point left twice, okay, so you will get 0.143, and of course we don't have a year yet, so we'll say to the x. Okay, and that would be my formula, and this is y equals, alright, that would be my formula. Okay, so this is what this looks like. Okay, now at this point what I would do is I would grab a calculator because you could fill out any piece of information you need just by substituting in for x. Okay, so in this case I see this next one says after 3 years, so I'm going to go to my calculator, I'm going to type in 6,500 times 1 minus 143. Okay, close my parenthesis, hit my caret key to give me my exponent. In this case, my exponent will be 3. I'm going to hit enter, and I get 4,091. Come on. 0.25. Okay, since this is money, right, we're talking about cost, we would only go out to the hundredths place. We don't go any farther than that. All right, so there's your first one. Okay, it's, again, a decay problem here. So again, pay attention to what keywords you have here, and depreciates would be your keyword in this case. So go down to the next one. All right, talking about animal species here. It says the population of a certain animal species decreases at a rate of 3.5% per year. You have counted 80 of the animals in the habitat you are studying. Write a function that models this. Okay, so again, this is decrease is my special word here. All right. This tells me I'm using decay again, so that means 1 minus r is going in the middle. Okay, so first off, we have 80 animals. Okay, we have, it's 1 minus r, right? My rate is 3.5. Again, move your decimal place 2 spots. You get 0, 3, 5 here. Okay, and of course, we have x. All right, and this is equal to y. All right. So now at this point, you would be able to, you could graph this, you could begin plugging in numbers for x to figure this out. Technically we could solve this, but we're going to do, instead of, figuring out, graphing this, we're not going to graph it, okay, obviously, because there's no graph here. Okay, let's figure out what the population is after 5 years. Okay, so we're going to look for, after 5 years, what does this population look like? Okay, so what I'm going to do is I'm going to plug it in. So 80 times 1 minus 0.035, and then of course the x is no longer x, it is 5. It's our substitution, all right? And that is exactly what I'm going to type into my calculator. Okay, so 80 parenthesis 1 minus 0.035, caret key to the 5, and I find out that there are roughly, let's see, it says 66.9 animals, so I don't know if you guys know what 0.9 of an animal is, so I'm going to go ahead and round that up and say there are 67 animals left, okay, in my pen. All right, so those are 2 examples here. You'll try one on your own when I send out the Google form for this, okay. All right, the other type of function we have, we like to call, these are for continuously compounded interest. And our favorite part about this is it's a nice, easy formula. It's PERT. Okay, everybody likes PERT. Okay, A is going to be your amount in the account. P is principal. E is actually a function on your calculator, so you're going to actually use the E button on your calculator. Oftentimes, it's with the LN button. It's usually second to that, so you're going to have to try to find that on a calculator. Okay, rate of interest. Okay, so what is the interest rate? And then how, time in years. So how many years is going to pass by? So this is what we're going to be using for this next 2. We're going to use PERT. Okay, so this says suppose you invest $1,050 at an annual interest rate of 5.5%. Compounded continuously. How much money will you have in your account after 5 years? Okay, so what I'm doing here is I'm going to go ahead and I'm going to fill in my pieces, all right? And once again, you want your rate to be a decimal, so you're going to have to convert it, all right? So first off, I'm just going to make a little list off to the side here. We are using PERT, so, we're using PERT here, so P, E, to the R, T. Okay, so sometimes people like to keep a list of things. It's up to you if you want to do this or not. I usually like to, just to make sure that I have what information do I actually have. In this case, they give me the P, the R, and the T. So what I'm solving for is the A. Remember, E is actually a function. It already has a value, and you're going to use that from your calculator. So the P for us is 1,050. Okay, the R, 5.5%. Again, move the decimal point 2 spots. So if I do that, I would get 0, 5, 5. Okay, and then for the T, time, we're going to go 5 years. And literally, guys, what I'm going to do is I'm going to sub those values in to the equation that I have. So P is 1,050. E is a function, R 0.055, and then T is times 5. Okay, so when I do this in a calculator, okay, what I'm going to do is I'm going to go ahead, I'm going to type in my 1050, all right, then I'm going to find my E key. Okay, so usually, again, it's with the LN, you want to usually hit second, and then E will be there, so you're going to be looking for that. So you open up your E, and it already opens up a E with a caret key and a parenthesis. So it's asking you what is the exponent. So you just fill it out. The exponent is 0.055 times 5, and then close that parenthesis, hit enter, and you will get your answer. So in this case, how much money we will have in the account will be 1,382.36. So there you go. All right, so it should be pretty straightforward as long as you can find your E key. You'll be all right on these. Okay, nice simple formulas. All right, one last one. Okay, again, we're investing. Okay, let's see, I've got time. Okay, so again, still using part here. So, you know, we got our P, our E, our R, and our T. Okay, in this case, I'm just going to substitute right away in case you don't like using the list. Okay, so we invested 1,300. Okay, E is our function. All right, and then the rate is 4.3. Again, move the decimal place twice. Okay, so if I do that, I have 0.043. Okay, and then we want after 3 years, so multiply that by 3. So there's what we're going to type into our calculator. Again, straightforward. Go to the calculator, find your E key, okay, and then type in inside that parenthesis up top 0.043 times 3. Close it, and then hit enter, and you will get your answer. So in this case, our answer is 1479. So $1,479 or $1,479. Okay, so there you go, guys. I will, make a little notes check thing for you on this. So just be ready to do some stuff. Also, there will be some stuff from the Monday or Tuesday's notes, depending on when you watched them. Will also be on that notes check. So make sure you know how to identify growth and decay.